All right, hi everyone. Welcome back to section 7.3 video. And we're continuing on our 7.3 lecture series where we're looking at operational properties that the Laplace transform can be applied to. We previously have learned the first translation theorem that was over the s-axis. And now we're going to learn about the second translation theorem, which is going to be over that t-axis that we previously established. So translation. It's just another fancy word for, shift. We're shifting over a t value. So we are going to define what the second translation theorem is. So the general piecewise defined function of this form, like f of t minus a times u of t minus a, that's the unit step function, is going to be the piecewise function 0 for t values of 0 to a, and then f of t minus a for t values greater than a. So this piecewise function, it might not seem like it now, it might seem kind of random, but it plays a significant role in our next theorem, which is that second translation theorem. Okay, because wherever the Laplace f of s is multiplied by an exponential function e to the negative as, the inverse Laplace of that product, inverse Laplace e to the negative as f of s, is a function f of t shifted along the t-axis, which is in this figure right here. We are shifted along this t-axis. And so what this is the second translation theorem. We're shifting a specific value of a. Okay, so here is the second translation theorem. Okay, so if f of s equals the Laplace of f of t, which it most certainly is greater than 0, then the Laplace of f of t minus a times u of t minus a equals e to the negative as times that Laplace f of s. So that is the second translation theorem. It helps us when we need to Laplace specific terms, mostly outright, but also with an initial value problem, we might need to use this second translation theorem. So to have it handy, we also desire to find a Laplace transform of just a unit step function. So here it is right here, the Laplace of a unit step function, u of t minus a is just e to the negative as over s. Okay, so second translation theorem, Laplace of a unit step function. And one last thing before we try out some examples is an alternative form of the second translation theorem. So we've been looking at, f of t minus a times a unit step function in the previous theorems, right? Well, what if we just have like a quote regular function g of t multiplying a unit step function? This is where the alternative form comes in. So second translation theorem, alternative form, we have a unit step function multiplying a regular function g of t. So the Laplace of that is going to be e to the negative as times the Laplace of g of t plus a. Okay, so with notation, it's always hard to identify what exactly we are doing. So let's go ahead and try out some examples. So here we're going to use the second translation theorem. So we're going to find the Laplace transform of this specific function. F of t equals 2 minus 3 times a unit step function u of t minus 2 plus unit step function u of t minus 3. So we want to find a Laplace transform of that. So what do we need to do? Well, we're going to Laplace it. So Laplace of f of t equals the Laplace of 2 minus 3 u of t minus 2 plus u of t minus 3. Okay, so Laplace of f of t is just, f of s. And so what we can do is separate these out to using the linearity property. Laplace of 3 u of t minus 2 plus the Laplace of u t minus 3. And we could take the constants out, take out the 2. So it'll just be Laplace of 1 minus 3 Laplace of t minus 2 plus Laplace of unit step function u of t minus 3. Okay, so Laplace of 1, we know that to just be 1 over s. So this would just be, 2 times 1 over s. The Laplace of the unit step function u of t minus 2, we could just grow up and use this well-known fact. So let's write that down. So here I'll say, maybe I could erase this and write it in between. So recall the Laplace of the unit step function t minus a is e to the negative as over s. So this would rewriting it 2 times 1 over s. Laplace of 1 is just 1 over s minus 3 times e. Here a would be 2, a would be 3, e to the negative 2s over s plus e to negative 3s over s. Okay, so if we could clean this up a bit, 2 over s minus 3 e to negative 2s all over s plus e to negative 3s over s. Well, that is the Laplace transform. Okay, so just an example of finding a Laplace transform of a unit step function, and if it has more combining parts, using the second translation theorem. Okay, so let's move on to the next example, which is the second translation theorem, but this time we're using the alternative form. So we want to find a Laplace transform of the function f of t equals cosine of t times the unit step function u of t minus pi. All right, so we want to find the Laplace of cosine of t times a unit step function t minus pi. So how do I know I need to use the alternative form here? Well, it's because it's cosine, which is sort of a regular function if you quote unquote regular times, so multiplying unit step function. So that's why we need to use an alternative form. Okay. So in that case, what is the second translation theorem? So, recall the second translation theorem alternative form, from the previous page is g of t times a unit step function t minus a equals e to the negative as times the Laplace of g t plus a. So, you know, here cosine of t is g of t, and then pi is going to be a. So the Laplace of this function cosine t times u of t minus pi is going to equal e to the negative pi s times the Laplace of cosine of t plus pi. So what is the Laplace of cosine t plus pi? Well, we don't know exactly, but what we do know is that this is a trig identity that cosine of, for example, theta plus pi is the same thing as negative cosine of theta. So what cosine of t plus pi actually is negative cosine of t. And so we can take out the negative. So this would be like negative e to the negative pi s Laplace of cosine of t. And the Laplace of cosine of t, we should know that it's from the basic Laplace table, but it would be is negative pi s times s over s squared plus 1. So recall the Laplace of cosine a of t equals s over s squared plus a squared. And here we just have like a 1 in front of the cosine or in front of the t. And so this is what we end up with. We could clean it up a bit. I like to write the exponential in the latter side. So I could say like negative s over s squared plus 1 e to the negative pi s. And so that is my Laplace transform. Okay, so these are two examples using the second translation theorem alternative form and just using the second translation theorem. And the main idea is just finding the Laplace transform of unit step functions. So that's our goal with these problems. Okay. So that's it for this video. Thank you for watching. In the next one, we're going to take a look at the inverse of the second translation theorem. But we'll see that for the next one. Okay, take care.